Alright, here we are again in the C-can. Today in this video we're tackling compressed air and then probably hanging the second hose reel for water. Probably not hooking it up, but today we're focusing on compressed air, my concept around it, what I'm doing to hook it up, what material I'm using, and my choices there, and then the control scheme for the compressor as well. Alright, in this video there's not going to be too much for the assembly footage. I'm just going to kind of skip it, keep it to a minimum this time around, but anyways, the basic plan we're doing here is this normal, I'm going to call it a normal compressor. Framing compressor is what I'm going to be using. Anyone will work, and the control scheme we're going with will work with anyone as well. That's the beauty of it. Regular 15 amp circuit is good for this guy, as long as you're not running real far out, which we aren't. Anyways, this is going to sit in the back corner of the C-can, right where that pile of wood is, under that dust cyclone in the back. And it's going to live there, and we're going to hardline down the pipe rack to this reel, and then eventually once we're done that, the water reel will go on this side of it just, and Bob's your auntie. To do this, I've chosen both pre-made hoses of the hydraulic variety because they are the most economical at Princess Auto. Even given their slightly reduced diameter in the fittings, we can live with it. They're actually cheaper than the air hose variant that don't have the slightly reduced diameter in the fittings. 3/4 inch galvanized pipe, just because honestly this whole lot of stuff came from a Home Depot over a year and a half ago when I knew what I wanted to do, but just wasn't ready to build it yet. When it was on old pricing, and it was actually cheaper than black iron or any commercial equivalent at the time. So I bought it, and that's what we're going with. We also got a couple ball valves, some Milton fittings to go with our Milton Quick Connect of our odd style. We have a check valve, which will be going, I got this guy off Amazon. I believe this might actually be stainless, but anyways, it was like 20 bucks, along with the gauge for another 20 bucks off Amazon. Pressure gauge. That'll be going on the end of a whip, like so. That'll be coming off of our hardline system and connecting to our compressor on the floor, so that you can pull this out and take it where you need to go for renos, whatever that isn't C-can air. And then for a control scheme, because anyone who's familiar with one of these knows that if you just unplug it while it's compressing, the motor stays loaded, and then depending on when you plug it back in, the contact's still closed, and the motor's still loaded from the tank, so it doesn't want to start up again, because the pressure switch on the side also acts internally as an unload. So what we're going to do is the switch on the wall isn't going to be cutting the power off to this guy, it's just going to be control for a relay over here, and then also a CT of sorts, which we're going to go over later. But the concept, just to get you guys interested, is that you flick the wall switch, it will close the relay, which will turn the compressor on, which will be the power side to switch it on. But while it's maintained, we're going to have this in series to the hot contacts, so when we have current going through the CT, it will actually maintain this switch closed until this pressure switch actuates that the compressor is full, therefore having no current running through our CT, which will open this. So basically it's a turn on and then turn off, but it will let this finish filling up, so we never have to get into a state where it is loaded when it stops from the switch on the wall. Hopefully that wasn't too long-winded. It'll end up in this 6x6 mounted somewhere up high on the back wall, and it'll be tied into one of our 3/4 inch EMT runs to be fed off the panel and switch that we put in already, because I knew I was going to do something like this. Anyways, let's get to it. Alright, so I'm going to do my best at explaining these over these two hand-drawn drawings, obviously, I have made. This is more of a traditional control scheme drawing, where we have line and neutral, so line on this side, neutral on this side. This doesn't represent physically how things are connected, only electrically. So to start from the beginning, this right here, this 520R, I believe I used 20 amp for this project, but 520R, 515R, either way, is the duplex receptacle that our compressor is plugged into. Right here is part number, just for an example, and an image. Coming back up, starting at the top left of the drawing, we have S1, which is our Decora toggle switch. I believe I have this on here. Rocker Plus, it's the commercial version. Once that closes, it completes a circuit through the 120 volt coil of our control relay or power relay, whatever you want to call it. This guy right here, our Finder 66 series. Just 120 volt coil closes that. As soon as this closes, it fires this dry contact, which is part of this relay, which then completes the circuit to our compressor through our receptacle. While that's happening, if this current sensor, which is what they call this guy, this Greystone high output AC current sensor, CS625, if it sees current, as in the compressor is pulling electricity, it has, it's 12 amps or whatever it likes, this here will actuate, which closes its dry contact up here, which also seals in across our 120 for our control relay. It's quite simple when you put it on a piece of paper like this. Hopefully that makes sense. It's moving to the next drawing to make this a little bit time-wise. This is more of a physical representation and something you do in trade school somewhat. When you draw physically the boxes that are in your project, and then you would draw your wires and your morettes. So you can, generally it's just like done for counting conduit fill, so you can see how many conductors you use. So starting from here, we have our 120/240 single phase panel, drew a little breaker, drew a neutral bar. We are using two current carrying conductors through a main 2-inch EMG to our ceiling mount gutter. In this gutter we split off the hot, which comes down to our Decora wall switch, only drawing one, even though it shares a box with the exhaust fan currently in the install, but for simplicity version, there's our wall switch. That comes back up. We have three conductors coming from our ceiling gutter to our 12x12 it turned out to be, which has our relay and our current sensing relay right here. And hopefully this is drawn out well enough so you guys can see it. But it's the same drawing as I just previously showed you, but kind of a realistic installation of it. Hopefully that helps. 10x10 by 4-inch deep JB, upgraded from a 6x6 because tried building it in that and it's just real tight. And we got one 4x4 box, two Decora duplex receptacles. Currently the dust collection's on the right and the compressor's on the left. This is half switched, so if you're not using the CNC, which drives this relay at 12 volts to turn on your dust collection via G-code, you could just manually put your hand in the corner and just plug it in. As an alternative for now, we might have another switch sometime later, but that's what this relay is and what this guy is, which is a voltage rated 18 or 20 gauge pair, so it actually legally can be in the same conduit. Everything else is here. We got our current relay and our power relay for the compressor circuit, which drives both top and bottom of the duplex, because at one point in time I might add a automatic dump valve at the bottom to let out the moisture automatically, depending on how heavy we use this. Obviously it might not get used that much, so this is our guy. And if this doesn't make sense, I encourage you to continue watching, where I will do a actual line drawing of what the hell's going on here. Alright, we're back looking at the installation one more time. Same setup over here. I've got a couple more fittings that came in from Amazon and a little hose for another blow down or whatever we're going to use over here. It's just hanging up there. It works nice. But what we're going to do is, right now I'm guessing there's about 15 psi in the system. This is unregulated, so there's not very much. And it's been off for about a week since I've used it, so we're just going to turn it on. I hope you could hear that. Our framing compressor in the back corner here is turned on. We're just going to see how long it takes to fill up. And while we're in the middle of filling up, I'm going to basically show you the whole thing. So basically, come over here to blow yourself off or whatever at the end of doing some work, say. You have no pressure because it's been off for a couple weeks, but you need to blow down. So now we can use it, but we don't want to wait for the compressor to fill up to turn its power off because it won't unload, so we just come over here and hit our switch. So as soon as that compressor is done filling up, it will open our control circuit and it will no longer have power to latch back in about 3 or 4 days when the pressure drops to the point where the pressure switch is no longer made and it would normally start the compressor. Hopefully that makes sense to you guys. Alright, so hopefully the why and the how of this video made sense to you guys. Ask any questions in the comments. I will do my best to field them in a timely manner, but sometimes that works out, sometimes it doesn't. Anyways, thanks for watching.